Next is the digital microwave equipment introduction. As you can see here, the analog microwave has already been discontinued. So we will focus on the digital microwave. Here, the digital microwave communication can be divided into few categories. For multiplexing, we can divide into PDH or SDH. On the capacity, we can divide into medium to low capacity and also to large capacity. On the structure itself, we have three different types of digital microwave: trunk microwave, split mount microwave, and all outdoor microwave. So the first one is a trunk microwave equipment. Trunk microwave equipment is divided into four parts: BRU, MSTU, SCSU, and BBIU. It is high cost, high capacity, therefore suitable for the long-haul transmission and backbone mobile communication. It is all indoors except for the antenna and the feeder. The all-outdoor microwave equipment having four parts: RF signal processing unit, IF cable, IF and baseband signal processing unit, and the service and power cable. The last one is the split mount microwave equipment. It has the antenna, RF unit or the outdoor unit, IF cable that connects to the RF to the IF unit, which is the indoor unit, and this is called the split mount because there is some parts in the indoor and there are parts on the outdoor. The split mount microwave equipment. This is the focus for the RTI 900 series. The antenna, the function is to focus the RF signal sent by the ODU, outdoor unit, enlarge the signal gain. The ODU, the outdoor unit, is used for the RF signal processing, conversion between the IF signal and the RF signal. The IF cable is transmission for the IF service signal, ODU management signal, and the supply power for the ODU. The IDU, which is the indoor unit, is for the service access and the distribute multiple modem and so on. Split mount equipment, the installation. The installation can be done by separate installation and a direct installation. As you can see in this picture, this is separate installation. Separate installation means that you need to have a soft waveguide to connect from the antenna to the ODU. When there is a direct installation, the ODU is directly installed on the antenna. There are two types of generally used antenna, which is the Kasai green and the paraboloid antenna. Commonly, diameters are used within 0.3 meters to 3 meters. Several channels in one frequency band can share one antenna. So as you can see here, transmission channel 1 up to channel N, and from the receive side as well, channel 1 up to channel N. For the antenna aligning, the radiated power of an antenna basically distributed to the main lobe and to the side lobes, as well as the rear lobes. The objective of the antenna adjustment is to align the main lobe of the local antenna to the main lobe of the opposite antenna. Change the direction vertically or horizontally. Meanwhile, use the multimeter to test the RSSI level at the receiving end. These two examples are the wrong way to do the antenna alignment, while this one is the correct way of doing the antenna alignment. There are four antenna specifications. The first one is the antenna gain, the input power ratio of isotropic antenna, PIO, to surface antenna, PI, when getting the same electric field intensity at the same point. Second is a half power angle, 3 dB beamwidth. From the main lobe deviates to both sides. The points where the power decrease half are half power points. The angle between the two half power points is half power angle. Approximate calculation formula is shown as here. The third one is a cross polarization discrimination, XPD. The suppressive intensity of power received from expected polarization PO to the other polarization PX. It should be more than 30 dB. The formula is given as here. Antenna protection ratio, which is the last specification for antenna. It is the ratio of the receiving attenuation in antenna other lobes to the receiving attenuation in antenna main lobe. The 180-degree antenna protection ratio also be called as the front or rear protection ratio. For the outdoor unit, the main specifications of transmitter is a working frequency band. One ODU can cover one frequency band or some part of a frequency band. Second is the output power. the power at the output port of a transmitter. The typical range for the power is from 15 to 30 dBm. Next is the frequency stability. The oscillation frequency stability of microwave device is from 3 to 10 ppm, pulse per minute. Transmitting frequency spectrum frame. A restricted frequency scope is frequency spectrum frame. The main specification of receiver. First is the work frequency band. The receiving frequency of local station is the same with the remote station. Second is the frequency stability. The requirement is from 3 to 10 ppm. Noise figure. The noise figure of digital microwave receiver is from 2.5 to 5 dB. Next is the pass band. The typical value is 1 to 2 times of transmission code element rate. Selectivity. The suppressing ability against interference beyond transmission bands. Then, lastly is the automatic gain control, AGC range. The automatic control the gain to keep the same IF output power level when receiving RF power level shift in a range because of fading. The function of the indoor unit, IDU, is to access service such as E1 or STM1, process the RF COH and conversion signals between the baseband and the IF. It is shown as the diagram here. So, in summary, we have gone through the classification of digital microwave equipment, the functions of the components in split mount digital microwave equipment, the parameters of antenna, parameters of ODU, and lastly, the function of IDU. Thank you for watching.